Let's now consider where the nephrons fit into this macroscopic renal structure. So let's imagine we have a renal pyramid here. So here's one of the renal pyramids. This is the base of the pyramid at the top, going down to the apex. This would be the papilla at the bottom. So this is an enlarged version of one of the medullary pyramids. Now what we find in the kidney is there's basically two sorts of nephrons. And the first type are called cortical nephrons. Now if that's the outside cortex of the kidney there, the outside part, then the cortical nephrons have their renal corpuscles near the cortex. So here we see a renal corpuscle. Here we have the capsule, Bowman's capsule. Then there'll be a first convoluted tubule where the kidney nephron loops around on itself to make it longer. So the renal corpuscle consists of the Bowman's capsule here, but also of course we need a blood supply. So there's going to be an afferent arteriole going in to the glomerulus, and there's going to be an efferent arteriole going out. The glomerulus being the ball of capillaries within Bowman's capsule. Collectively, the glomerulus and the capsule we would call a renal corpuscle. Then in the case of this cortical nephron, after the first convoluted tubule, there's going to be a loop, but the loops are relatively small in cortical nephrons. And actually about 80 to 85% of nephrons are these cortical type of nephrons. The ascending loop of Henle then passes very close to the afferent arteriole. Then there's another convoluted tubule where it twists around on itself, and then that drains into one of the collecting ducts. And indeed many nephrons are going to drain into a collecting duct. So that's the structure of a cortical nephron. Two parts, the renal corpuscle and the renal tubule. Blood enters the afferent arteriole, is filtered in the glomerulus. The glomerular filtrate goes through to Bowman's capsule. The filtrate goes round the first convoluted tubule, round this short loop, and these loops are often called the loops of Henle. The ascending loop then passes very close to the afferent arteriole. Then there's a second convoluted tubule, and then we have the collecting duct. So most nephrons are of that type, and they're described as cortical nephrons. Now the next sort of nephron are called juxtamedullary nephrons. Juxtamedullary. And juxta means close. So juxtamedullary nephrons have their renal corpuscles close to the medulla. So let's now draw a juxtamedullary nephron. So the renal corpuscle in this case is going to be close to the medulla. And there's going to be a first convoluted tubule, and then this is going to enter down this loop, this nephron, which is going to become the loop of Henle. The tubule is going to pass down into the cortex, and as it does so it becomes thinner, but these dip right down deep into the lower parts of the medullary pyramid. Then this thin tube's going to go back up, great big long loop, and it will become thicker again as it goes up. It's got a bit of a kink, that shouldn't really be there. Now, obviously, at the start of this nephron, there's going to be the afferent arteriole taking blood into the glomerulus. There's going to be the glomerulus, which is the ball of capillaries within the Bowman's capsule, and then the blood is going to leave via an efferent arteriole. And again, the ascending loop is going to pass very close. Mine's got a bit bent, it would be straighter than that. It's going to pass very close to the afferent arteriole. The afferent arteriole, which is associated with the same nephron. Then there's going to be another convoluted tubule, a second or a distal convoluted tubule, and then again this material is going to pass into a collecting duct, and again that collecting duct is going to go down through the medulla all the way, they probably wouldn't be there, they'd probably just go down, all the way down to the base here, where the urine is going to drain out at the papilla. So that's a juxtamedullary nephron. So that is where the nephrons lie in position to the components of the renal parenchyma. The renal corpuscles, the glomeruli and the Bowman's capsule, are always in the cortex. In the case of the cortical nephron, the loop only dips a little way down into the medulla. In the case of the juxtamedullary nephron, the corpuscle again is in the cortex, but now lower down next to the medulla, and then we have this long loop of Henle. And the purpose of this is it allows concentrated urine to be formed through this long loop of Henle. As the ascending loop comes back up, it gets thicker again. It passes very close to the afferent arteriole, goes into a second or distal convoluted tubule, and anything that's not reabsorbed is going to go into the collecting duct, till eventually, when it comes out at the base, it's going to be urine. So there's a drop of urine formed, and that is going to pass directly into a minor calyx associated with that particular medullary pyramid. As we've seen on the previous diagram, once the urine is formed here, it's going to go into a minor calyx, into the major calyces, into the pelvis, and on down into the ureter, onto the urinary bladder. So that's the overall structure of the kidney in terms of the cortex and the medulla, and it shows why it's like this, because the renal corpuscles are in the cortex, the loops go down into the medulla, and the collecting systems pass down through the individual medullary pyramids to the nipples or papilla at the bottom there, in order to drain into a minor calyx to be drained away to the bladder. So next we need to look at the structure of the nephron in more detail.